Okay, I want to talk briefly about a very large brain structure that sometimes gets sort of short shrift, and it will pretty much in this class as well, unfortunately. It's the cerebellum, right? The structure that sits off the dorsal surface of your brainstem, right, and is linked by those great big kind of axonal cables that we refer to when they're cut as the peduncles, right? And the cerebellum is an extraordinarily tightly wound sort of structure. You should notice lots of sulci and gyri right here on the surface. In fact, the cerebellum contains about as many neurons as you find in the rest of the cerebrum. It is quite a tightly packed and complex structure. It also, in addition to containing to consisting of a cortex, like an outer surface that's a gray matter cortex, deep within it are significant numbers of deep nuclei, of cerebellar nuclei. So it's like another mini brain here attached to the back of your big cerebrum, and yet it's typically dismissed as just being important for movement, right? So it is important for movement. It actually should illustrate to you to some extent about the importance of movement. Anything you're doing, right? Any kind of behavior you're generating, walking around, talking, moving the larynx, pharynx, expressing, all these things, involve, complex coordinated movements. And the cerebellum does get a great deal of sensory information input, from sensory receptors that are, providing information about, how extended muscles are, limbs are, and things like that. So it knows where your body is, actually how you're extended. In addition, it gets information from the inner ear, from the vestibular apparatus in the inner ear. So information about, where you're moving, how your head is organized, when you're tilting from one side to the other, and things like that. So vestibular information is also integrated in the cerebellum, and the cerebellum then can help to inform or improve movement output that's going to be generated also by the frontal lobes. So and of course another set of structures that we've discussed, right, that are critical for movement are the basal ganglia, right? So there are a number of structures actually in your nervous system that are quite interested in generating and maintaining appropriate movement. Typically with loss or damage of the cerebellum, if there's strokes in the cerebellum or tumors in the cerebellum, people suffer from significant loss of coordination. So they develop a particular form of movement dysfunction that's referred to as ataxia, which is literally sort of loss of coordination in terms of movement.